Hi everyone. So the question we're taking here is longest repeating character replacement. So let's understand the question. The question says that we have to return the longest substring containing the same letter. And so we're given a string S and an integer K. So what we can do is we can change any character in the string S and change it to any uppercase letter. And we can at max perform this k times to see what is the longest substring that we can get. Okay, so the way, let's see how do we do this. Let's say I have this string. Let's take this string for better understanding purpose. So in here, what we do is the brute force way is what we'll see. We'll just firstly what we'll do if we were just told that we can do this manually. So how would we approach this? We would first you know, count the frequency of every character, right? So A has a frequency of 1, 2, 3, 4. B has a frequency of 1, 2, 3. So if I were to change anything here, I would change B. Why not A? Because you know, changing I mean keeping A is good. Why? Because it's the high, because it requires least amount of work. So what I would do is I would keep all the A's and I would change the B's. So what is my K here? 1. So in here, if I change this B, what happens? I get consecutive A's of length 4. So now my max length would be 4. Can I change any more B to A? So if I change this B to A, what would happen? My consecutive length would be 2. So it's not maximum. However, I can get 2 length as well. Or 2 from here as well. So 2 here. Other way. And then if I change this B, I can change only once, right? So if I change this B, what happens? My length would be 2 again. So my maximum would be 4, right? So this is the maximum length I can get. But doing this brute force requires, big of n squared time complexity, which is not very ideal for, s dot length 10 to the power 5 because we'll get time limit exceeded. So in order to solve this, we are going to do one thing. What are we going to do? Let's say if I have this window, I can keep on expanding the window. But wait, before that, let's get to one thing. So why were we changing just one character and not the frequency of B? Why? Because my total length of the string, let's say in here, my total length was what? 3, correct? Let's take AAB. So my total length is 3. And I could change B because if let's say and my frequency of A up until here is 2. So my maximum count is 2. So now if I do 3 minus 2, it is greater than equal to 1, which is my K. Now since this formula holds true, I was able to change this B. And when I move forward, I can move forward now. So now what happens? I get an A. So now my we can see the length, maximum length becomes 4. And then when I come to this B, what happens is my length is up until here. What is the length? 1, 2, 3, 4, 5. Correct? And what's my maximum count of A? It is 3. If I do 5 minus 3, we get 2. And is 2 greater than is I mean this is not K is 1 and 5 minus 3 is 2. So 2, sorry, wait. What I mean to say is my total count up until here is 5, correct? And my frequency of A is what? 4. Now, I can't change this. Why? Because I've exhausted. What have I exhausted? I've exhausted the K characters. So I could only, this K is taken. So now my K is 0. So I can't change. What I'm trying to say here is that whenever my, sorry, I missed this. This should be less than equal to. So what I was trying to say is that in here, my count of A becomes 3 and my total length is 5. So 5 minus 3 is 2. So now 2 is greater than 1, which is my allowed K. So I can't perform this operation. So that is why when I reach here, I know that I cannot move more to the right. I can only shrink my left. So we'll shrink left by 1 character at a time. So yeah, this is the entire intuition behind this code. Now let's do that. So now the formula that I come was length minus maximum count should be less than equal to K. Correct? Yeah. So this is it. So let's do the calculation here. Let's say we have a variable called max length. We initialize it to 0 and in the end we will return the maximum length. Right? Now I'll tell one more thing. We'll have left pointer, correct? So my left would be initialized to 0 and I would have a right pointer. If sorry, for int right is equal to 0, right is less than equal to what? S dot length and right plus plus. So now we are always going to calculate the maximum length in the array after doing some processing. So that would be calculated via mat.max of maximum length and right minus left, which will give us the distance between them and plus 1 for the number of elements. So this is how a max length is calculated. Now, we have to check if, now let's say we have to first, there should be a way in which we can store the frequency of every character. So let's create an array which will store frequency of every character and let's initialize it to n, which is s dot length. So my n is s dot length. So what do we do now? We have seen this character. So first let's get the character. My character will be s dot character at right, correct? And what will be the index of that character? Or let's store this character in ch. So character ch is this. Now what do we have to do? We have to store the frequency of this character. So my frequency of this character. So now my question says that we only will have uppercase English letters. So what happens now is that to get the index where this is stored, we'll do minus it with a. And then we'll just plus plus. So now we have updated the frequency, right? Now we need to check if our current, if we can do the maths here. So what does the math say? It says that if length, what is the length right now of my current window? So the length of my current window will be right minus left plus 1, right? So if my right minus left plus 1 is the length of the current window. So if my length minus max count, so let's say we want to get the max count. So let's just write max count right now. We'll find a way to get this max count and then it should be less than equal to k. If this is okay, then if we can, we can proceed, we can expand, right? But if this is not okay, it means if this is greater than k, then we need to shrink left, right? So how do we shrink left? We do left minus minus Before doing left minus minus, we remove that character frequency. We decrement the character frequency of that character from the frequency array by 1. So we'll do ch minus a minus minus, right? But not ch minus a. So the character at left. So s dot character at left, right? So this is how we do it. And yeah, so now what do we need? We need a way to store, we need to get a way to find the maximum count. Now see, ch is not used anywhere else. So we can instead do this. And yeah, so let's find a way to get ch. Sorry, maximum count. Now there's this thing. Let's say when we are expanding, okay? Let's see. When we expand A, B, A, B, B, A. So when we get A, we can expand to another A, correct? So in this case, my maximum count will change, right? But when we go to B, again, since it's, that window is allowed, it's fine. Then we can change this to A. Then when we go to A again, we can, our max count will increase. But when we go to B, then we need to decrement something from A. So when we decrement something from A, will our max count? Maximum count is what? Maximum count. The maximum count will not change when we decrement this. So only when we are incrementing will our maximum count change. Right? So instead of manually iterating through the frequency array, we can just have a variable called max count initialized to 0. And then what we can do is, in here, we can say that, wait, ch s dot character at length. So now what we can do is, I'll check my maximum frequency. So now my maximum frequency would be math dot max of max count and what? My current, if it will only change when my current window expands, right? So this frequency. So this will be my maximum count, and we'll do the checking. So yeah, this is how it goes. And let's run this code. Yeah, it should be right less than n. So just checking what went wrong. Yeah, let's fix this error. So we should have incremented left. Running the code now. Submitting this. Yeah, so this should not be hen, instead it should be 26. Right, because we're just storing uppercase letters, so that's why. Let's use this test case. And running the code again. Submitting. So now we know that our space complexity is just constant because we're using this frequency array. which will at max store 26 characters. So that is why our space complexity is big O of 1. And coming to the time complexity, our time complexity is big O of n. So yeah. So yeah, that was it from my end. Thanks for watching. Bye.